It's public information. I would look.
Oh, all right. All right, we're going to start with the supplemental problems and then go backwards to see if you guys have any questions on the rest of the review. This is your time to ask. All right, the question yesterday came up, are there going to be any end behavior questions on the exam? And the answer is yes and no. All right. Do you understand if you look at the limit as x goes to infinity, that's technically an end behavior question? You shut that door for me. You guys understand that's technically an end behavior question. What is the y value approaching as x goes to infinity? The y value is the function height, right? So this is the one where you look at the behavior of the numerator, behavior of the denominator, and if it's polynomial for both, you can reduce. And then if it's depending on what the remaining function is, will tell you the limit. It's very general, but remember, if it reduces to 1/2, is it 1/2 a horizontal asymptote? It's getting close to 1/2, either from above or below. We don't know. What if it reduces to like 1/x? Is there a horizontal asymptote? I'm going to make up a new problem. What does this reduce into? X squared over x cubed, which is 1/x. Does this function have a horizontal asymptote? Because for this one we reduced it, and we got 1/2. For sure, there's a horizontal asymptote at y equals 1/2, right? How about for this one? Is that a yes? Just the head nod. Okay. So this one was for sure because it was a constant, and if your function's acting like a constant, horizontal asymptote. For this one, it's a function, but now you have to model that function as x goes to infinity. And if you plug in large numbers, 1/1,000, 1/1,000,000, 1/10,000,000, it's getting closer to 0. Therefore, y equals 0 is a horizontal asymptote. Remember that? It's been a while. So that's how you answer that kind of question. So end behavior model, like show that e to the x is a good right end behavior model? No. But end behavior model-ish question like this, where it's a limit as x goes to infinity? Yes. Ooh, you got a product rule and a chain rule within. We okay with that? Product rule, chain rule? Average rate of change. Average rate of change. Question on that one. Five or six? Okay.
6B.
6B. All right, find that open interval where the particle is moving to the left. Did you interpret that as where the velocity is negative? Do you understand that?
I didn't really know where to start with that.
So do you remember where I was walking in front of the classroom way too much? Okay. And I said, if the velocity is positive, I'm moving to the right. If I stop, my velocity is 0. If I'm moving to the left, my velocity is negative. So to find the interval where the particle is moving to the left, you should interpret it as find the velocity and find out where the velocity is negative. Now, it's going to change. It could change from negative to positive, but it's going to have to go through 0, right? So what you could do is find the velocity and factor, which for a lot of you is that the F word. Okay. Factor it, t minus 5, t plus 1, set it equal to 0. Those are the times when the velocity is 0. So now you test. This is like a first derivative test, all right? You test in the velocity function before -1, between -1 and 5, and then after 5. And on this interval is where the velocity is negative, from -1 to 5. Open interval, because at -1 and 5, it's not moving to the left. The particle is stopped. So -1 to 5 would be that one. Does that help?
Mhm.
Cool. I gave just kind of a general question for number 8. You guys remember looking at velocity graph? What do we have to be careful with when we're reading a velocity time graph that's like this? And if I say, where does the particle change direction? What do we have to be careful with? Do you know what I'm asking you? VFT. You remember this? What do we have to be careful with? The old ricochet. Yeah, so if I say, where does it change direction, the velocity graph has to actually pass through the t-axis, right? Pass through, not just bounce. What would that be a situation of scenario? I'm walking in front of the room. I'm walking to the right, and then I keep. I didn't change direction. All right. What about when is the acceleration negative? Well, if that's velocity, the acceleration is the slope of that graph. So you're looking for negative slopes on that graph. Positive slope, negative slope. Do you guys agree the negative slope all the way through here? Positive slope, negative slope. Those intervals would be the intervals I would label as negative acceleration. What are they doing out there today, guys? Like what? Give me a play-by-play.
So he's rolling in the chair, sleeve up.
See him rolling?
Sweaterman is standing up. He's finger guns. He's eating some Cheerios.
Arm wrestling.
It's arm wrestling.
Oh
no. We're locked in. Oh,
Electric guitar sweater guys.
Yeah. All day. Moving tables. He's like, it's too weak. It's too weak for my table.
I got okay, yeah, let me know. We should definitely be friends, even if we don't room together. But keep me updated. No. I'm not reading with the first person you talk to. Probably not even the second or the third.
Why do you want to be a teacher, Miss Russell? It's a benefit. I think they felt pretty easy. All right, how do we feel about that one? How about maximum speed? I'd have to give you either labels or make it pretty obvious, but what if the graph was like that? It's getting bad. This is getting bad. Even though the velocity is negative there, speed is positive, right? Speed's always positive. So the magnitude of that value, if it's like -10 meters per second, the speed would be +10. And if it outweighs any of the other speeds, then it's the maximum speed on that one. I guess I could have used the bug example for this one. Could have used the bug. Who wants to describe what's happening from 0 to 2? Lizzie, you got a smile on your face.
No, this isn't me calling you.
I didn't call on you.
Oh.
Just you look happy today. You happy today?
Yes.
That makes me happy. Tyler.
Acceleration is positive but constant, and velocity is increasing. 0 to 2.
I would agree. Okay. The bug is moving to the right, and the velocity is increasing. Okay, as it moves to the right. Then from 2 to 4, the bug is moving to the right at a constant velocity. I guess you could say speed, but let's use the units, the dependent variable, I guess you'd say, that's given to us. All right. From 4 to 6, the bug is moving to the right, but its velocity is approaching 0. The bug changes direction at 6 and moves to the left from 6 to 8. Good. But as it moves to the left, the velocity is becoming more negative, and then the velocity is negative but getting closer to 0. Okay, makes sense? At what value of t does the bug change direction? 6. Easy. All right. We did the supplemental questions. What else would you like to ask me about on the exam review? This is open season.
That's great. Great movie.
What is the 4 excited response?
What are they?
Yeah.
Two optimizations.
What is really any question?
Is it like 4 optimization?
4 optimization. That's risky.
Maybe 2.
4 boxes.
You think there's an optimization on there?
I agree.
If there
That was
is an
a risky
optimization and it
trade.
asks about a cylinder, will you give us the formula?
Yeah.
There's gotta be one.
The question was, would I give you a formula if it had to do with volume or surface area of a cylinder? And the answer is yes. Cylinder.
Gotta be at least one.
Oh yeah?
I'd say 2 optimizations.
On the extent of that's bold.
There's probably
At least
Put a lot of eggs in that basket.
definitely.
I mean, you wouldn't need calculator for optimization.
You wouldn't need it.
That makes sense. There's definitely at least one.
Or
maybe it's one of
But what if the teacher hated grading those so much that they just didn't want to put that on there?
Well,
I put it on multiple choice instead.
ooh.
Oh, it makes a lot of sense.
Kind of boring.
That's a mid.
Boring grading is good grading.
But then,
This is all about me. This exam is all about me.
Oh, okay.
So
Is that 2 million points?
2 million.
Did you do that for the freshman exam?
I wanted to.
You should have put like a top list question, like 1,000 points.
Bonus question. 100 points. All right, what questions do you have for me? Exam review questions. Jackson, you got anything good?
No.
You ready for this, Jackson? When is this exam?
Friday.
Right here, 7:39. I'll be here. I'll be here.
We'll all be here.
What happens if you're late?
format.
You gotta come back. You gotta come back at
That'd be deep.
12:35. Minus 50% if you're late. Go.
Never mind.
Is that
That's my rule.
You can do that.
I don't want to start grading exams at 12:35.
You don't. You just have to start grading mine at that time.
This is all about me.
Everybody else is starting to grade.
Yeah, you're gonna be really
What questions do you have for me? Madison, you ready? You good? Tony? Tessa, you good? Kylie? Yeah. Doug?
Yeah.
Questions for me?
I don't think so. No.
Nothing.
Nothing. Feels good. Feels good.
Front row?
Here's a joke.
You want a joke?
No way.
Christmas
Two Christmas jokes.
Nerd alert. Excellent wisecrackers.
Excellent.
Table of contents. Oh, I had a good one. I was told a good one the other day. A book fell on my head. I only have my shelf to blame. I accidentally ate cat food. Don't ask me out.
Or you do one. You don't know one. Oh yeah. You can find that, and then once you get.
How many French people in here? Students do you have in here? French students. None? Should I go first anyway?
Go for it.
I don't trust French food. Like, it gives me the crepes. Crepes. To ride a horse or not to ride a horse? That is the question.
Oh, where do you have
All right. Any others you have a question about? Have we done many fencing problems? I think we have, but you didn't ask about. Like you were fine with them. Do you want to go over one? Oh, the partitions one. That was rough. Let's do this one. A rancher has 300 feet of fencing to enclose a pasture bordered on one side by a river. Ooh. Pasture. River. Which should be blue. Pasture.
Oh, this is, come on.
I'm just going to throw all the criticism deep down. Just understand students get really touchy exam week. Just give them some grace here. Don't criticize them. Don't take it out on the grading of the exam. Let's call this X. X and Y. All right. As soon as I read 300 feet of fencing, I'm thinking, ooh, that is a number. That is a constraint. Perimeter. What was that? 300. It takes. Man. We need to bring those middle schoolers in and teach you guys how to behave. There we go. 2x plus y equals 300. What is our objective? X, Y is the area. What's the area of this paddock? XY. And y is 300 minus 2x. Yes? What should we do with that? Yeah, you probably have a graph on this one. I might solve it by hand just for fun. I would not use the product rule because I'm just going to distribute. A prime of x, the derivative is 300 minus 4x, yes? My critical point is when 4x, so 300 minus 4x equals 0. So when 4x equals 300, so when x is 75. Yes? Yes, yes. All right, well, that's a critical point. Does it mean it is the maximum value? It is going to yield the maximum value? Not necessarily. I mean, Yeah, but not necessarily. All right, what should we test to make sure this is yields a maximum? Again, you have a calculator, but wouldn't you plug in a value before 75 and after 75 into the derivative? Yes? Here's the derivative. Let's plug in 50. What's 300 minus 200? Positive. Positive derivative. Let's plug in Hondo. 300 minus 400. Negative. The derivative changes from positive to negative. Max. Okay. What's x though? It's the width. The length would be 300 minus 150. 150. 75. And what did the question ask? Find the dimensions. Find the dimension. Well, we just gave those dimensions. 75 by 150. It's not very bad, is it? For fencing. My nephew's a really big fencer. He's really good at fencing. And
Building fences?
no, like whatever you do. So I'm gonna go to his next fencing tournament. Make a sign. Defense.
That's his first name, so with a D.
That's Trent. You know Trent.
Oh, Trent.
Trent Hopkins.
Yeah.
Oh, Trent.
He's a
big sword guy. He's a big sword guy.
Yeah, you see his coat of armor.
Oh, yeah. He runs like once every year.
Yeah, he's gotta work it in. Have you seen his plague? What's it called? Plague mask? What's it called?
Oh, the plague doctor.
Plague, yeah. Have you seen that one?
I only have to wear.
Something. He's quite the young man. Yes, like
Is there going to be a question like 55 on the review?
that's good. I don't know. It's on the review, yeah.
On the test.
On the test? I don't remember. I have a bad memory. 55?
Yeah.
I mean, yeah, it's a maximum first derivative test question. I think it's fair. What would you do for that one? Good. Take the derivative, set it equal to 0, get critical points.
Yeah.
Find out which one yields a maximum value. That's the employees. It was a decimal. It's like 13.694. Is that it?
0.694 for an employee.
Yeah, so we kind of talked about this. It sounds silly. It's actually realistic. I gave the example of my wife. Okay, my wife is a teacher. She used to teach full-time. Now she's a part-time French teacher at Louisville. She teaches one class a day. Now, a full-time teacher is considered teaching 5 classes. Anything less, you get a partial salary. So she teaches 1/5 of a full schedule. So she gets 1/5 of the pay. Okay? On their records, they have a full-time French teacher and she's the part-time. So they technically have 1.2 French teachers on the accounting records of the district. Does that make sense? So as far as time goes, they have 1.2 teachers. So I could see a scenario where you could have a weird decimal of an employee. They don't work quite full-time.
Would you want us to put the decimal or find if so it goes 13.694? Would you want us to see which one is 13 or 14 greater and put that, or would you just
I would have to accept either. If I didn't word it very well, like this one, to obtain maximum monthly production, how many employees should that be assigned? If you put 13.694, I would have to accept that. If you put 14, I'd be like, oh yeah, I could see how, it's closer to 14 employees. Maybe we should do 14 employees.
Because I did it and then found out if 13 or 14 would be greater, and then 14 is greater. So.
Yeah. So I would probably put maybe to the nearest whole employee.
Okay.
Other questions? Layton, was that enough of a description for that one?
That was pretty good.
Pretty good.
It was phenomenal.
That's too much.
What else? I feel like I should remake this exam. You guys are like criticizing me. Only 4 extended response? Oh, I should put 10 optimization problems on it.
I mean,
I'd enjoy that. Just make the entire exam optimization problem. Make it the Jane problem.
Don't put the J. The spicy problem on there.
That's a wild
Spicy
one.
ones?
Yeah.
Is there spicy
Is
ones
there
on
atomic ones on there?
We're talking like.
E channel?
I don't think so.
They're dropping atomic right now.
I only missed 4 questions on it, so I don't think it's that bad.
Huh?
4 questions. 4 out of the 25.
I did better than you.
Not perfect.
Already all missing those. Either are we?
I didn't miss it. I'm just kidding.
Did you take it?
Yeah.
Cool.
Well, when you already know the answers.
How?
Did you
You made the exam.
He made it, but he hadn't hit right.
Oh, they just toss it
Right,
right
I put distractors in there.
to distract yourself.
That would be great. Ah, it got me. All right, how else can I help you get ready for this, other than giving you the answers?
Yeah, AP scale.
They're not AP questions.